Okay, good morning, everybody. How you guys doing? Good. Is everybody caffeinated? Okay. So today we're going to do a presentation called Tell a Robot to Shake Its Booty, and we'll have some booty shaking later with a live robot, hopefully. So what is a booty and how do you shake it? So, not that kind of booty. So, to shake one's booty is to swing the hips and buttocks from side to side or to dance with energy and enthusiasm. And we'll have our little friend Sphero here do that later. But I can show you it just in case we do have technical difficulties later. We'll just run this 7 seconds to prove that it has happened before.
Shaking my booty.
Alrighty. So this talk has an origin story. I'll try to make it short. Last year I was new to my role as a technical evangelist for Login with Amazon, blatant product placement. This is how I'm paying my trip over here. Though I'd built a few logins, I was new to OAuth, and once I had the basics of our profile API under my belt, I wanted to see some of the other things that Login with Amazon powered. One of them was the Alexa voice service. We vended the access tokens for that. So what else could I do with Login with Amazon? I built an Alexa voice service client in Node. But of course, they already had one, which we'll be using today, not mine. But for a WoW demo to the AVS guys, I wrote an Alexa skill that would take commands to control a robot connected to the machine running the skill's back end. One of those commands was the Shake Your Booty video that we just saw here. Now, figuring out how to make a website control a robot was so much fun, I knew it had to become a pitch for a conference, and as long as I could fit Login with Amazon into it, I could come and do things like this. So let's continue. Now, there are 3 stages of voice control. The first is getting the words. The second is determining intent, because you have to then figure out what those words mean and what the user wants. And the last thing is conveying the commands. So now that you've got that intent, you now have to do something appropriate with it. So how do we get the words? Before we turn the sounds into words, we have to get the sounds. So here, tried and true libraries to wrap web standards like Guest User Media or WebRTC are your friends. I like Recorder.js, it's really useful, and I actually built my own version of it called Small Recorder. You can find it on my GitHub. It's basically just a variation on Recorder.js that outputs 16-bit 16 kilohertz mono PCM wave format, which is not only good for Alexa voice service, for AWS Lex, which just released, which is like Alexa's brain as a service, and also for, like training CMU Sphinx, and it's even good for the Arduino Wave Shield because it's a really small speaker and it plays that sort of well. So when I pitched this, I was hoping to talk about web speech, but the web speech API is still, let's say, in progress. Only one browser has really implemented it in full, and that's still behind flags, or actually it's prefixed, excuse me. And I wrote developer documentation for IE. I love the web. I've been on the web. My first website went live in 1995 in 100K of space at Earthlink. As I like to say, I have bad web design habits that are old enough to drink. So, pardon me. So, I was excited about doing something with the web, but luckily, because I could do the Alexa voice service in the web, I could continue to do this. So to capture the words, send them to Alexa, which turns them into text. And now that we've turned the words into text, we have to get that intent, and Alexa helps with that as well, because we have to figure out what the statement means. And this quote's about as accurate as most quotes you'll find on the internet. But Mr. Einstein has very good advice for us. When we're turning words into action, this is, you can actually sort of write a regex for this to understand that, when we're creating that shake your booty intent, we have to understand the different ways that people might say or convey that intent. So we have one, which is the move, which could be shake, move, waggle, rock, whose, a, your, or that. And what? Booty, behind, backside, tail feather, moneymaker, caboose thing, and groove thing. And these are to tell the robot to move in a specific way. So this is a capture of my interaction model screen for the Alexa skill. The first part is your intent schema, and we'll look at the JSON in there in a more visible and complete form. It has 3 intents, which are basically the shake intent, the roll intent, and the end intent. And as you can see, I've got the slots with a name and a type. The name actually can be used as a variable in later returns from Alexa or to other parts of your app, so that, if I say shake your groove thing, and I use shake in Alexa saying shaking my shaker, my shake, then Alexa's going to say shaking my groove thing rather than shaking my booty when I've told her to shake your groove thing. So it's fairly simple. This is all the JSON there is, and you basically have to give Alexa your intents. The last one is the end intent, which closes your skill, because you have to open and close your skills with Alexa. So after that, we have our slot types, and you saw the slot types in there: my, part, rolls, shaker, what, close. And so these are some of the words to give Alexa an idea of what's going to be used. And it's really fairly simple, because if you click the edit button, it just opens a box below and you add the various possibilities in there. And the last thing is your sample utterances, and as you can see, I'm saying for the shake intent, shake, our shake variable, anything that could go in there, a, your, that, and then my part, which could be any of those things, booty, tail, feather, etc. And we have that also for roll intent. Now notice, I can give Alexa, roll forward 10, and Alexa will use it. This is to give examples to Alexa, which will help hint to users and also help Alexa figure out what you're wanting to do. So I've given it 1, 2, 3, 4, and 5, but I can actually give it a higher number when I talk. And this is an interesting part here. If you go through many of the Alexa tutorials, they're going to push you to use a Lambda. I did originally, but I misconfigured my Lambda and it couldn't reach out to the robot server. And trying to debug that, I thought the solution was way more complicated and I was going to have to do way more moving parts to be able to reach out, instead of like, oh, I set one bit wrong when I was setting up my Lambda, which I later figured out. But I figured out while I was trying to get around that I could actually run my own skill server using the Alexa app server package from NPM. And that can actually be used in production. I don't know if Alexa would recommend it, but you can use it in limited production like I'm going to use here. And it's good, for running skills, not just testing them. So this is Alexa app server on NPM. And then one of the things that I realized is if I was running the app server locally, then I could actually build my robot control skill directly into my skill. The robot control functions directly into my skill, because I also have a version of this where the skill could be run anywhere and then reaches out to a server that is just running the robot. And so for the first time I did this demo internally, I was running 3 local servers, one for my Node skill, one for my Node Alexa voice service client in the browser, one for running my Alexa skill, and one for controlling the robot. And so the node client in the browser would reach out to the Alexa voice service. The Alexa voice service would reach out to the other server that was running my skill, which would then reach out to the robot server, and the skill server and robot server were both tunneled out to the general web so that they could actually be accessible. Also in the configuration, you'll see account linking, and this is where you can get a unique identifier and a bit of profile information based on the user's Amazon account, and that uses, come on, log in with Amazon. So, because this is a very purpose-built demo, I did not actually put that into my skill, although I just did a demo last week of Amazon Lex, where I built a Cordova app that consumes the Lex APIs, and for that, Lex is on AWS, and you need an AWS token, so you can actually get a consumer account token with login with Amazon that you can trade using Cognito to get an AWS token for Lex. And so I demoed all that last week. Alrighty, so we've got our words into action. Now it's conveying the command. And if you were like going to be setting this up as, say, a multi-tenant app, then you definitely want to use something like Login with Amazon, where you could then set up your accounts and be able to be sure like which server you needed to reach out to for which customer. That way you could have unique identifiers and set that up. So the last part of this, getting command to the robot, I'm not a hardware guy. I've tried to mess around with Arduinos. I took Electronics 1 in 1982 in high school. I learned what an ohm was and how to calculate wattage. But beyond that, I'm really not good with wiring and soldering. So I let other people build the robots. And this is a Sphero. If you, downstairs, one of the booths is actually giving away a BB-8 from Star Wars, which is built on that platform. And you can use it with the same library that we're going to talk about, which is Cylon.js. And that's also available from NPM. The one thing about Cylon.js is if you're going to install it on a Windows computer, you need to either install serial port first and go through some of the tricks with serial port, because it may want to actually compile itself to get access to your serial port, because you need that to make the Bluetooth connection. So for Windows, Cylon is possible. I have proven it, but it does take a little more installation voodoo than it would for, say, a Mac or a Linux machine. So this is the Alexa skill code that we run on localhost. As you can see, we bring some of that intent information back. Our slots, we have both the name and the type. And so we have our intents, our shake intent, our roll intent, and our end intent. And they basically take the information that Alexa's now passed them and do something with it. So the shake intent, our shake it is, we have no variables involved with the shake it. It is pretty straightforward. You'll see that next screen where we'll go through that code. So the shake intent is up here. And all this does is it, shake your booty's been recognized, it shakes it, and then it comes back and says, shaking my, and then whatever you used as that term. With the intent, for the roll intent, it's now taking a direction and a strength. We call it duration, but in Sphero it's a strength. And you can see that we're calculating it as, we'll do that in the next screen. And then the end intent, it just says, you tell Alexa to close the skill, Alexa says closing, thank you. Closing the skill and thank you. So, let's go to the robot code. Now the robot code is pretty simple. We start the Sphero. You know, we set up our Sphero to wake. It will then connect via Bluetooth to the Sphero robot that has already been paired with the laptop. This is a little touchy. We may have to try it once or twice to get an actual connection. And if this was like a really Bluetooth active zone, we might have to try it 3 or 4 times. And then we have our function shake it, that's just duplicated there. And simply it starts an interval that runs 15 times and changes the orientation of the roll by 180 degrees and simply does a very low power roll of a strength of 50. You'll see that our rolling strength here on rolling, we're doing basically 20 times the strength plus 10. So we're going anywhere from 210 to 2010 versus 50 for the roll. So we're really not gonna like do 2010 because I don't want Sphero rolling into a wall, but we'll do a couple of rolls as well. And then we just basically, we know that we've set up these different directions in our intents, samples, forward, back, left, right, backward, ahead, and we've just assigned the angles to them. And that is all the code for this skill, entirely all the code. So, well, why did I have that? So anyways, we are going to now go to our demo. So let us bring up the right screens. And we'll bring over the Alexus skill testing tool here. And we'll tab, bring over our robot, our server, which we'll have to launch. Tab. And we'll bring over, we're not going to bring over the webcam because I'm going to have to use that for a microphone. So let's do the, start up our server. Oh, first off, we need to get this into pairing mode, and it'll flash until we pair. Let's try this. There we go. Boom, solid light. We have connected, first time. Thank you, demo gods. So let's open the Alexus skill testing tool, and do we have our volume up on the headphones so they can hear? All right, so let's see if this works. Alexa, open robot control.
Connection successful. Sir, what is your command?
Shake your booty.
Shaking my booty.
Roll forward 3.
Rolling forward 3.
Roll back 5.
Rolling back 5.
Roll right 6.
Rolling right 6.
So that's the way it works. My kids love it. They love giving commands to Alexa. And you can basically build this, this is not a published skill. You sort of do have to log into it via EchoSim with your developer account if you're using it yourself. If you were to get it yourself, you would publish it and be able to access it from an actual Alexa device that was tied to your, that wasn't tied to your developer account. You can just load the skill. So let's get back to our presentation. Alrighty then. So So this is how you get a robot to shake its booty. It's actually a lot more simple than it seems, but it was a lot of fun to figure out, and it got me a trip to Amsterdam. So I appreciate you guys coming and listening, and if you want to talk about the new variation on Alexa, which is AWS Lex, which I talked about at OSCON last week, I'd be glad to talk to you guys later after the presentation. I can show you my little mobile app that I created. All right, and I believe that's the end. And the funny thing is I added in more slides so that this would run longer because it was so short the first time I gave it, and it's still pretty short. Yeah, I can take a few questions. I have to be careful because Amazon PR has not certified me for taking questions. Yes?
Hi, I noticed in Hi, I noticed in the first few slides, you gave an example of, I think there were synonyms that you were selecting, like shake your booty and wobble, whatever it was. Mm-hmm. And I did take a quick look into developing Alexa skills, and they said that, yes, you have to hard code synonyms like that, and they mentioned something, if I'm right here, about 100 or more, and I saw you were starting to get quite a long list there, and I'm wondering, is that done to make it easier to attract more developers and make it faster to develop? Because I would have assumed that using a pre-existing ontology, such as WordNet or something, might be more efficient, or have you found that it's more efficient to just hard code it?
So here's the thing. I am not an Alexa evangelist. I do log in with Amazon, so I don't know their logic, and I can't address it. If you want to connect with me afterwards, I can always get you to an Alexa evangelist or an Alexa product manager who can answer that question. I can talk about my experience with creating a skill, but I cannot talk to their reasoning.
Thanks.
Over here.
It's funny because I basically had the same question, but I have another one. Mm-hmm. Right now, it's only possible to use several code words to start Alexa. Is the Amazon voice service any way to work around that? So you can make your own app to say, for instance, I want to call it Bobo. So now you have the wake word Alexa. Is there a way to say Bobo, Bobo shake your booty?
If you're using the Alexa voice service as an API, and you're creating your own device that consumes that, you can set whatever your wake word is. Your wake word is turning on your mic, which is working with your hardware. Basically, they have set their wake words for the Alexa devices. I don't believe that they have a custom wake word for, they have a few different choices, but they don't allow you to do a custom right now, and I don't know if they have any plans to, but I do know that, when I created my AVS client, I was just pressing a button, like in that demo, you didn't use a wake word, you press the button to activate the mic, and if you're creating a app using like Raspberry Pi or some other, making your own Alexa device, you can set your own wake word in your own software that's consuming the AVS APIs.
Okay, cool.
All righty. So, thank you very much. And if you want to see an Alexa type app listen to a knock knock joke, come see me later.